All right, so now let's go over similarity. Before we actually look at similar shapes, we do need to go over two things, ratios and proportions. Now, what is a ratio? Yeah, it's the comparison between two things. You use ratios a lot in probability. We went over what a ratio was. In gambling, right? If it says the chances of a horse winning is 1 to 2, that's a ratio. It means that they have 1 in 2 chances of winning. So a ratio compares the size of one number to the size of another. And there are actually 3 ways to write a ratio. The first is a fraction. So like I said, a horse has 1 in 2 chances of winning, 1 over 2. You can write it as a colon, 1 colon 2. Or you can do it in words, 1 to 2. All of these mean the same thing. They're comparing the magnitude of one number to the magnitude of another. Now, the reason we go over ratios is because when we're thinking about a similar shape, and I say the two shapes have a ratio of 1 to 2, what do you think that means? So, if I'm telling you this triangle compared to this triangle, together, these two triangles have a ratio of 1 to 2. What does that mean?
The smaller one is double half.
So, this, you said the exact same thing, yeah. So, this first triangle is half of the size of the second triangle, right? This is double. If I say it has a ratio of 1 to 2, it means that the bigger triangle is double the size. Now, sometimes they're going to ask you to solve for sides on a triangle. So if I say that, we have 1 to 2 on side lengths here, and then we have x to maybe 6. They're going to ask us to solve for x. And how we do that, I know it's kind of easy to see on this problem. Oh yeah, okay, it's 3. But normally what we would do is create a proportion. Now a proportion compares one ratio to another ratio. So if I was going to set up a proportion here for this little example I have up here, how do you think I'm going to set it up? There's multiple ways you can do it. Yes, 1 over 2 is equal to x over 6. And then what would I do to solve this? You cross multiply. Now, okay, so I have a couple things to say about this. And this is very important for you to understand because when you get to Algebra 2, hopefully you solidly understand proportions. If I had this, would I cross multiply? Do I do x equals 6? So, what is the difference between this and this?
One of them has an equal sign and one of them has.
Okay, so the key to cross multiplying is knowing you can only cross multiply when there is a what between two fractions? An equal sign. Say that in your head right now. Cross multiply have to have equal sign. Equal sign. Okay? Here, what would you do to, I just can't stand today. Okay. What would I do to solve this? What? What would I have to get? What do you have to do to add fractions?
Common denominator.
Ah, oh my gosh, you have to get a common denominator.
I thought you were talking about the other one.
Oh, I'm like, what?
That's why I said
All right, so here, you don't need to write this, but I want to explain cross multiplying. Say you'd never heard of cross multiplying. What do you do to solve this? No, never heard of cross multiplying. Say you're trying to get x by itself. What do you do first? Ah, you multiply by the denominator, right? So here, I multiply both sides by 2. The 2's cancel. What do you do to get rid of the 4 in the denominator on the other side? Multiply by 4. Oh, what did you just actually do? You just cross multiplied. Yeah. So it's just like a short step of multiplying by the other's denominator, okay? So we cross multiply by multiplying 4 times x and setting it equal to 48. And then we divide by 4. X is 12. All right, guys. How do we now solve this second example? Oh my gosh, you cross multiply again. So we're going to multiply 8 times 2 and we get? And then multiply 4. Now, how am I going to write this? Should I write 4x plus 2?
4x plus 8.
Ah, I need to remember that the 4 is being multiplied by both the x and the 2, right? And then I subtract 8 over, and I get 8 is equal to 4x, and you divide both sides by 4, and x is 2. Any questions on this one? Okay, so now, before we apply this to actual similarity problems, let's go over what similar shapes look like. So down here, it says two shapes are similar if they have a constant scale factor. So what do you think this means? What does this mean?
The scale factor for all the sides.
Yes, that you need to be thinking about, okay, what do you multiply 6 by to get 18? 3. You need to make sure that on that smaller triangle, you're always multiplying by 3. Now, sometimes it's not easy to find the scale factor like that. Sometimes it's going to be a fraction or a decimal. So it's easier instead to think, okay, what is 18 similar to? What side do you think 18 is similar to? The 6, right? So to find the scale factor here, you divide, what's 18 divided by 6? Then, what's 24 similar to? 8. So you divide 24 divided by 8. Because I had 18 over 6, the bigger one over the little one, I need to make sure I'm consistent here and put the bigger one over the little one. And then, what is 30 similar to?
So
you do 30 over 10, and you get. So these all have the same what? Scale factor, meaning what?
But they're similar.
Ah. They have the same scale factor. Meaning the triangles are similar. And I'm going to do the symbol for similar. And if you think you're going to forget this, just put a little arrow and write similar.
I remember learning this in like 5th grade, I swear.
Yeah, most of geometry you've learned before. A lot of math is repetition. Like the first half of Algebra 2 is a little bit harder Algebra 1. Okay. Any questions on this problem? Yeah, so what does this problem tell us that's going to help us solve for x here? Shh. Ah, the two triangles are similar to each other. Yes. Now, how does this help us? What do we know about similar triangles? They have the same scale factor. They have the same ratio between their sides, right? So here we can compare one ratio, one set of sides to another set of sides, creating a proportion. So how would you like me to set up my first ratio, my first comparison between sides? Which one has both numbers in it? 6 and 10. So I can put 6 over 10. Shh. And then 6 is on the bigger or smaller triangle? Smaller. So what's the other side on the smaller triangle? X. So that has to go up top. And then what's the other side on the larger triangle? Now, is 4 the entire length of the big triangle? No. So what do you think you're going to have to do here? Ah, x plus 4. Because 10 is the entire length of the big triangle, you have to make sure you're using all the way from A to C. Does this make sense?
Yes.
Okay. So now what do we do to solve this? Cross multiply. Guys, you need to stop talking. Okay. So we're going to multiply 10 times x and you get? And then 6 times x plus 4. Good. And we distribute the 6 to both. Have I lost anyone? All right. And then we subtract 6 over. And we divide. Holy. And we divide by 4.
I guess that is some subway.
Oh God.
Any questions on this problem?
Hell yeah.
Now, if I had, instead of having this 6 and 10 here, had maybe a 6 here and a 3 here, would I need to use the entire x plus 4 length when I'm creating my proportion? No, because you can just do x over 4 equals 6 over 3. The only reason we had to use the entire length in this problem is because 10 was the entire length of the big triangle.
So how would you find AEB? Would that be?
Shut up.
Shh, what?
How would you find the other side? Would it be equal to x?
You couldn't.
Oh, just
Yeah.
curious.
Any more questions on this problem?
That's because there's not.